Good afternoon. Please come join us for our next speaker, Randall Degges with Okta. Let's give him a warm welcome.
What's up? So how's it going, everyone? Today, I'm basically going to talk about building modern applications with Okta and Amazon Web Services. So here's the thing. Almost all web applications require two things, right? The first is a place to run and host all of your apps, which is obviously Amazon that we all know and love, hopefully. And then the second is a place to store and authenticate all of your users. And that's where Okta sort of comes into play. So my name is Randall Degges. I run developer advocacy here at Okta. I'm a Python, Node, and Go developer, and my specialization is like web security. So Okta provides two services, essentially. The first is a dashboard service that makes it really easy for employees in your company to log into all the services that they use every single day. It looks something like this. So when you're an employee and you log into your Okta dashboard, you see this nice, beautiful UI. It has all the different services that you use and log into every single day. And if you click on one of those services, you get single signed on straight into the application of your choosing, and bam, you're in there. You don't ever need a username or a password or any sort of IT or help desk support because things just sort of work. Now, obviously, this is a really awesome user experience, but it's also awesome for like the IT team that's managing all of the employee accounts when they join the company. Because with Okta, you can have Okta basically provision these accounts for you when you join the company, manage all of your credentials, and it's just very simple. Now, fun fact, if you're wondering why this logo is blacked out, it's because Amazon did not allow us to actually use their image in the slides. Sort of ironic, I know. But anyways, the more interesting thing that we do, which is the part of the company I work on quite a bit, is we build a developer platform that makes it really simple to build secure web applications. And that's what I'm going to sort of walk you through today. And the reason I think this is cool is because authentication sucks for pretty much all of us developers. And the reason why is that since the 1990s, I think 1994, authentication has, for the most part, been completely unchanged. Up until several years ago, people have been doing the same thing the same way with very little change. So let's take a look at that. So the most common form of web authentication, like hands down, is form-based authentication. This is what you all probably know really, really well. And this is what happens when basically a user, when they go to authenticate to your website, they send like their email and password, stuff like that. You as the developer, you write some logic to check the email and password, make sure that it's valid, and then log the user into your application using typically a cookie. Pretty standard stuff. Where this gets complicated, though, is right here. This is what you as the developer have to do, right? So doing really simple stuff like validating an email and password, that's really easy. You don't need any help with that. But what's hard is making sure that the password hashing algorithms are updated over time to support newer standards, making sure that you implement like things like password reset, single sign-on, multi-factor authentication, social login. Making sure all those things are done in a really nice way is where it gets tricky. And most development teams aren't experts at this, and they also don't really like doing it. So our idea is to sort of outsource that and make it better. Now, a handful of years ago, all of us in the security industry got together and sort of decided, well, developers are building these applications, writing all of this logic themselves, and it gets really tricky to do that. So we developed the OAuth and OpenID Connect protocols, which is a standard. Everyone sort of is getting on board with it recently, to make this a little less painful. Now, there's a number of different ways to use OAuth and OpenID Connect to handle web authentication. I'm just going to walk you through a little example app that we're going to be making through the course of this talk, which just makes things a little simpler for you. So imagine you have a web app, example.com, and it has three components. There's www.example.com, there's login.example.com, which handles all the login logic, and then there's the dashboard, which is the dashboard your users actually log into and work with. So what happens is when a user is on the website and wants to log in, they say, I'm going to click this login button. The website, which you build, doesn't know anything about authentication. So what it does is it redirects the user to this login domain. On this login domain, the user is going to see a brand new login page, enter their information, and send it back up to the server. Pretty standard so far still. We haven't done anything special. And what happens here is once the user's been logged in, you're going to check their email and password and make sure it's legit. We're going to generate a JSON web token that has some user information embedded in it and redirect the user to the dashboard service that we're running. And finally, this dashboard service is going to validate the token, log you in using a cookie, and then let you into the application. This is pretty nice. And the best part about this is that login service in the middle can be totally outsourced to a company like ours, like Okta, to do all this stuff for you. That way you don't need to build this stuff yourself. And the real benefit here is separation of concerns, one of the principles in building any sort of software. And that is that you as a developer can build your website and your dashboard and all the business logic, but you don't have to worry about authentication and authorization at all. And that's pretty awesome. Now, some developers see this and they say, well, that sounds a little complicated. What I'd like to do is just offer some sort of social login or single sign-on for my users. That way, I don't have to worry about all this tough stuff that I would have to do otherwise. So here's a random example. Instead of Salesforce, this could be Google, Facebook, pretty much anyone. It all works basically the same. So in this flow, when a user goes to your website, they might want to log in with Salesforce. So they get redirected to Salesforce. Salesforce authenticates them, recognizes them. You receive their user information back from Salesforce. Now you as the developer need to process that user record, maybe store it in your database, maybe create a cookie for them, and then log them in. And again, the reason this gets tricky is because of this part right here. So when you as a developer have to integrate directly with a social login provider or a single sign-on service, things get messy really fast. So you need to understand the protocols. There's SAML behind the scenes there. In a lot of cases, OpenID Connect and OAuth. Making sure that you implement these things the exact right way that the provider requires can be really time-consuming and error-prone. And so again, Okta is really useful here because we have a bunch of pre-built integrations to thousands of different services to make this like a one-liner in your code base. And the fantastic part about what we try to do at Okta is everything we do is built on top of standards technologies. So everything we do is built on top of OAuth, OpenID Connect, SAML. And we basically try to do this so we prevent vendor lock-in. Because if you're building something on an open source protocol, it's really easy to migrate into or out of that system, and it gives you a lot of options, so you're not stuck. And the idea here is that if you use Okta and Amazon together, not only can you build the secure stuff using Okta, but you can build really scalable, modern apps on Amazon as well. And when you use both of those services together, you get a lot of really nice benefits. So what I'm going to walk you through now is just a theoretical application. We're going to architect it together, which is going to run on Amazon using a bunch of newer services, and then use Okta to handle all the security stuff. So the first part of this that we're going to be building is API Gateway. And I'm sure most of you are very familiar with this already, but the concept is really simple. It's basically a load balancer that also handles application routing. So let's take a look. Typically, in a standard web application architecture, when users make a request to your site, those requests are going to hit a load balancer of some sort. This might be an elastic load balancer or something else. Then that load balancer is going to pass your request along to any number of web servers behind the scenes, right? With API Gateway, it's almost exactly the same thing with one minor tweak. Instead of having a load balancer that just round robin assigns requests to backend web servers, you can actually get really granular and write logic to say, hey, if a user request comes in and it has this URL, I want to send that request to this particular server or set of servers. And the awesome thing is that it doesn't actually need to be a server. It could actually be other resources as well, which is where Amazon Lambda comes into play. So Lambda is probably my favorite technology and the most innovative one built in the last 10 years, I'd say, for web developers. And the reason it's really cool, well, actually, we're going to get into it. But the idea is that instead of building some large web server application, you can build a single-purpose function that Amazon will run for you, and you don't need any servers to make this work. So let's take a look. So back to standard web app architecture. At the end of the day, regardless of how complicated your infrastructure is, even at Facebook, right? A user makes a request, and it eventually gets to a web server. And the web server is just a long-running process. It might be on EC2 or ECS or any other service you might have. But it's basically always running, waiting for incoming requests that it can then fulfill, right? So the server gets a request. It says, oh, this user is trying to view this page, so we're going to show that to them. This user is trying to bill something, so we're going to do the billing option. And then you send a response back. Pretty standard. Now, with Lambda, things are a little different, right? So instead of building a web server, what you do is you take the functionality that used to exist in your web app, and you break it up into these functions. So imagine you're building a website that only does 3 things. It converts video files, it processes video files, and then it allows you to purchase video files. So in this scenario, Amazon can basically say, well, hey, if the user asks to convert something, we're going to provision this Lambda function. We're going to spin it up, run the code that you've defined in there. It could be Python, Node, Java, JavaScript, .NET, whatever. And then as soon as that code's done running, we're going to shut it down. And regardless of how many requests you get to do this stuff, Amazon will just run this function as many times as necessary in these little ephemeral containers. And the great part about this is it's pretty cheap. So Amazon bills you by the amount of milliseconds that it takes for this Lambda function to run. So it's nice because when you're running a traditional web server, right, you're paying for it all the time that it's up. Versus a Lambda function where you're only paying to actually run your lines of code like on demand as needed. And again, that's really cool because A, there's no servers, right? That means you don't really need an ops team to do things like configuration management, cloud formation setups. You don't really need any of that stuff. There's no ops team that needs to get involved there. There's also no maintenance, right? So when you have a server, you need to do things like worry about security patches, the latest version of Python or Node, just a million different things. With Lambda, it just doesn't matter because they're these ephemeral containers that Amazon maintains for you. And the biggest benefit of them all, in my opinion, is the scaling. So with traditional web applications, we all sort of collectively spend a lot of time doing capacity planning. We create these auto-scale groups to smartly deploy new EC2 instances and new ECS containers to manage all of our code to make sure we can support enough requests. With Lambda, Amazon just says, well, if you get 1 million requests, we will just run 1 million Lambda functions. So it's pretty simple. No effort needed. And if you put this all together, the architecture you get looks basically like this. So you have all of your user requests going to an API gateway instance, and that calls the appropriate Lambda function behind the scenes, and that's pretty much it. Now, Okta, you might be wondering, where does Okta fit into this? Because I rep Okta, and that's why I'm up here trying to make money for the company, right? But here's how it fits in. So there's 2 places you can use it. The first place is at the API gateway layer directly. So one of the really nice features that API gateway has is it can transform incoming requests and outgoing responses before any actual code is ran. So before any Lambda processes a request or any backend web server. And this is actually really, really awesome. So imagine that a user's logged into your website, and they have a login header, like an authorization header of some sort. And the next time they make a request to your site, Lambda gets the request, runs a second function, which talks to Okta, uses Okta's API to grab the user's information in JSON form, add that into the request, and then forward that to the Lambda function that's going to run to fulfill the request. Maybe the Lambda function that runs to process a video, for instance, will already have all the user information embedded inside of it. Doesn't need to know anything about login, anything about authentication. It's really simple. Saves you a lot of time. The next place you can hook Okta into this is in your Lambda functions themselves. So I mentioned earlier that Lambda supports a pretty wide variety of programming languages. Okta supports a lot of different developer libraries and SDKs to make working with Okta in your favorite language super, super easy. So basically, the benefits here are that with Amazon, you can build your apps really fast, deploy them easily, and you can get rid of your maintenance almost completely and never need to worry about scale. And with Okta, we basically give you one place to manage all of your users centrally, authenticate and authorize your users in a variety of different ways. There's OAuth, OpenID Connect, SAML, a bunch of other things. And then finally, we give you a really nice, simple way to secure not only just your web apps, but also your API services and your mobile apps with a standard set of developer libraries. So that's pretty much all I have. If you guys have questions, I can answer a few real quick. If not, I will be hanging out at the Okta booth over there, where we also have free stuff to give you. So you should definitely head over there after this talk if you haven't been there already. And yeah, that's all. Thank you.